Alright class, so this video is about inverse functions, and so let's get started. So for inverse function, I'm just going to read this here. It says an inverse function is a function that goes in the opposite direction. What that means is you kind of, whatever you're doing to this function here, it's when you look at the inverse, it's kind of going backwards. Okay, so I'm going to look at this example in just a second, but I want to read the rest of this. It says when that happens, the x coordinate and the y coordinate get switched. Okay, so what I'm going to do is I'm going to highlight this because this is where it gets very important. Okay, the x and y coordinate get switched. So that's basically what an inverse function is. Okay. So this example, we have a function here. F of x equals f of x plus f of x equals 2x plus 3, and that's what I have here. F of x is equal to 2 times x plus 3. That's technically what this is saying. Okay, and we have an ordered pair here. We have 4, 11. Again, remember it has many different ordered pairs, but this is just one ordered pair, 4, 11. Okay, what that, and just to review what an ordered pair is, you know, this is your x coordinate and this is your y coordinate. So if I plug in my x here, so you have 2, and if I plug in 4 here, I should get 11. So 2 times 4 is 8 plus 3, that equals to 11. Okay, so that's what that is. That's what the ordered pair is telling you. Now let's look at the inverse function. So if I were to just kind of take the statement and go backwards, it would be x minus 3 divided by 2. X plus 3, so the opposite would be x minus 3. And then divided by 2, since it's being times, I'm going to say divided by 2. And that would look something like this, x minus 3 divided by 2. Okay, but the more important thing I wanted to show you here is if this is the function 2x plus 3 and this is the inverse x minus 3 divided by 2, the ordered pair should get switched. Okay, so here I have 4, 11, and then my inverse would be 11, 4. If I look here, let's just check. So what's my x here? My x here would be 11. So 11 minus 3 divided by 2. 11 minus 3 is 8 divided by 2, and that gives me 4, which that's what we want. Okay. Another thing I wanted to say about inverse function is the inverse is usually written by putting a little -1 after the function name, like this. So you have f of -1 of x. So when you have something like this, you know we're looking at an inverse function. Okay, I'm going to show you a much easier way how we handle inverse functions. Okay, so the two ways we're going to show you is how by using algebra, and another way is by using a graph. The first example, let's look at this as find the inverse of the following function using algebra. Alright, so the first step, always when you're looking for inverse functions, so I'm just going to write the steps. Okay, the first step would be to switch x and y. Okay, so I go to my original, I see my x here, but where is my y? Okay, this goes back to the first lesson when we talked about function notation. F of x, remember, it's the same thing as y. Okay, so there's my y, so you have y equals 2x plus 6. Okay, so I'm just rewriting this. I'm just changing the f of x to y, and then I'm going to switch the x and y. So I'm going to switch these two around. So I'm going to put a x here, and then I'm going to put the y here. Once I've done that, the second step will be to solve for y. meaning we want to get y by itself. Get y by itself. Alright, so let's look at our how we do this using algebra. This part hopefully is a review for you. So to get this y by itself, I need to take everything away from this, right? So we have the -6. We're going to subtract the -6 from both sides first. When I say both sides, I mean both sides of the equal sign. So like just kind of put this little bar just to divide this, the left and the right side. That gets crossed out. So you have 2y equals x minus 6. It's just x minus 6. There's nothing I can do here. My final step is to take to get y by itself, I need to divide both sides by 2. Okay? Hang on. Divide both sides by 2. Okay, remember when you're dividing both sides, you have to divide everything on the left side as well. So it's not just the x or the 6, but the whole thing. So what happens here? The two get canceled out, so you have y equals x minus 6 divided by 2. So what happens here is you have to make sure to divide everything by 2. So x divided by 2 and then 6 divided by 2 as well. So just move the equal sign. And then here, this might look a little weird, but remember in front of the x, the coefficient is 1. So you have 1 over 2, or in other words, 1/2 x. I just, rewrite it like that. And then 6 divided by 2, that's 3, equals y. Okay? This looks weird, so let me just bring this down. Okay, but I did all this. Now I have to make sure that I write my answer properly. So here's what my answer is going to look like. We have here f of x equals 2x plus 6, and then here the f inverse, you write it like this. You write the function name and write the little inverse symbol of x. So this is f of x equals 2x plus 6. The inverse, f inverse of x would be whatever we got here algebraically, 1/2 x minus 3. Okay? So that's my answer. Okay. One thing that I wanted to show you here is how do I want to check my answer. So here I'm going to, actually let me write it in a different color. Here I want to check my answer. Check the answer in the calculator. How do I do that? Check the answer in the calculator. So what I'm going to do is, my first step is to put f of x in the calculator and y equals in the calculator. And then my second step would be to write 3 coordinates. Because eventually what I'm going to do is I'm going to look at these coordinates, and then I'm going to see if my inverse function, when I plug this in the calculator, the coordinates get switched. Okay, so let me take my calculator here, and I'm going to go to y equals right here. Y equals, and then I'm going to plug in my original f of x here. My f of x is 2x plus 3. 2x plus 3. Okay, and I'm going to go to my table, which is where I can find all of my ordered pairs, my table. And then what I'm going to do is I'm just going to write down 3 coordinates. So let me put this, let me organize this in a better way. So we have here f of x. The 3 coordinates for f of x are 0, 6, and then again you can pick any three coordinates. Just make sure, sometimes you'll get decimals here, don't pick the decimals, okay? Or I'm gonna pick 1, 8, 1, 8, and remember there's also negative, so maybe let's pick a negative. So we'll say negative 1 goes to 4. Okay, now what I'm gonna check in my calculator to see if I did my math right is, for my inverse function, I'm putting f of negative 1, showing that it's my inverse function. My inverse function should have the same coordinates, except they need to be switched. 6 has to go to 0. If 0 goes to 6, the 6 has to go to 0. 8 has to go to 1. And then 4 has to go to negative 1. Okay, so if all these coordinates get switched, I know that then I did my math right. So here's what I found for my inverse. My inverse function is 1/2 x minus 3. So I'm going to go to my y equals, clear out the f of x, and put it in my inverse. So 1/2 x alpha y equals 1. I just like to have a little fraction bar. So you have 1 over 2 x minus 3. Okay, I'm going to go to my table. So I'm going to go to second table, and I'm going to look here for my switched coordinates. So let's look over here. So we have 6. Does 6 go to 3? Let's check. I'm sorry, not 3. Does 6 go to 0? Yes, it does. 6 goes to 0. So this is, I'm going to put a little check here to say that worked. Does 8 go to 1? Let's check. Yep, 8 went to 1. And then does 4 go to negative 1? Yes, it does. 4 goes to negative 1. There we go. So since all of these checked out, we can be sure that this is the final answer. Okay, so I'm going to go ahead and circle it. And I'm pretty confident now that this is the right answer. You have to check at least 3 coordinates. Okay, sometimes you'll have 1 coordinate, but then some other coordinates don't match. You have just, if you check 3, that should be enough to make sure that they match. Okay. All right. Another example here. So same thing. What I'm gonna do is I'm gonna take my f of x. I'm gonna say, well, this is my y. So you have y equals negative 2x minus 4. I'm going to switch these, so this becomes x equals negative 2y minus 4. And then I'm going to solve. I'm going to say, well, I'm going to get rid of this, I'm going to add 4 on both sides. So this is x plus 4 equals negative 2y. Divide both sides by negative 2. And then, so you have y equals, remember there's a 1 here, so this is negative 1/2 x. The negative comes from here. And then you have 4 divided by negative 2 is negative 2. So my answer is my f inverse of x is equal to negative 1/2 x minus 2. Okay, so before I say this is my answer, let me check. It takes not that long to check and make sure you got the answer right. So for f of x, my original function here, it is negative 2x minus 4, so I'm going to put that in my calculator. My f of x is negative 2x minus 4. Let me make sure that was it. Negative 2x minus 4, okay? And then I'm going to go to my table, and I'm just going to write down 3 coordinates. Let me just move this. Now you can pick any 3, so I'm going to pick negative 2 goes to 0. Negative 1 goes to negative 2. And then, let me pick this one. 1 goes to negative 6. Okay. Now my f inverse of x, the inverse function, if I did everything right, it should have the coordinates switched. So let me switch them so I know what I'm looking for. Okay, now I'm going to go to y equals, I'm going to plug in my answer here. So you have negative 1/2 of y equals 1/2 x minus 2. And I'm going to go to my table. I'm just going to confirm, does 0 go to negative 2? Yes, it does. Does negative 2 go to negative 1? Where's negative 2? Up here? Yep, it does. So this one matches, this one matches. Does negative 6 go to 1? Yeah, it does. Negative 6 does go to 1. Okay, so now that I've confirmed the answer, I'm going to go ahead and circle it to make for sure that this is it. Okay. Alright, now there's just one more example I wanted to go through. This one, same thing. If I'm looking for the inverse function, I am going to change this to y, go to y equals 1/2 x plus 4. Before I do anything, I have to switch these. So you have x equals 1/2 y plus 4. And I'm going to solve. So I'm going to subtract 4 on both sides of the equal sign. So you have x, you have x minus 4 equals 1/2 y. This gets crossed out. And then to get rid of the 1/2, all I have to do is multiply by the reciprocal. Let me write a little note here for that. Multiply by reciprocal. Okay? What that means is, on the left side, if I multiply by 2 over 1, that means I have to multiply the right side by 2 over 1. 2 over 1 is just 2. What happens here is the 2's get crossed out and the 1's get crossed out. So all you have left here is y, which is what we wanted. We want to get y by itself. And then on this side you have 2 times x, which is 2x, and then 2 times negative 4, which is negative 8. So I'm saying that my answer is the f inverse of x is equal to whatever I got here, 2x minus 8. You can put a little inverse symbol here too, just so that you know where it is. 2x minus 8. Now I'm going to check my answer. So for my f of x is 1/2 x plus 4. I'm going to try to get 3 coordinates. So I want to write down just 3 different coordinates. Okay, so we have here, go to y equals, plug in your f of x, 1/2 x plus 4. Let me just change this. 1/2 x plus 4. We're going to go to the table and just mark down 3 coordinates. Now here, don't write down any of the fractions, just make sure you write down all the, any of the whole numbers. So you have, I'm going to choose negative 6 and it goes to 7. I'm going to choose negative 4 goes to 6. And then I'm going to choose negative 2 goes to 5. Alright, f inverse of x. Remember, if it's an inverse function, the coordinates have to get switched. So let me just switch them. 7 goes to negative 6. 6 goes to negative 4. And 5 goes to negative 2. Okay? Now, so I'm going to go to y equals. I'm going to plug in my inverse function that I found. Just to, here, all I'm doing is I'm just checking my answer. Okay? Go to my table. Now let's look at this. So the 7 go to negative 6. 7 goes to positive 6. I did something wrong. Let me see. 2x minus 8. What did I do wrong? Y equals, I have to check this again. 1/2 x plus 4. Go to my table. Did I write the right coordinates? Negative, oh, I did write this wrong. Negative 6 goes to 1, not 7. Why did I write 7? Which means that this is not 7, this is also 1. I think I fixed it. Okay, sorry about that. Let me check my inverse now. Let me plug in my inverse, 2x minus 8. I know I thought I did my math right, so this part I messed up on. Second table. Alright, now let's look at this. Does 1 go to negative 6? Yes, it does. Okay, 1 goes to negative 6. Does 6 go to negative 4? Let's check. 6 goes to negative 4. 6 goes to positive 4. And then negative 2 goes to negative 12. That's not what I wrote here. I should check the rest of the coordinates. Sorry about that. Well, I mean, I guess I'm glad I'm making this mistake so you can see that, you know, if you're not, that's the reason why we're checking. So 4, table, negative 6 goes to 1, negative 4. See, I think originally when I put in the function here, I put in the wrong one. Okay, so this is wrong. I'm sure this is wrong too. Okay, so negative 4 goes to 2, and then negative 2 goes to 3. Okay, which means all of these are wrong as well. Just erase something. 2 goes to negative 4, and then 3 goes to negative 2. Okay, all right, now, sorry guys, this is so tedious, but it's okay. I want to make sure, the point here is I want to make sure I have the right answer. Okay, last time. 1 goes to negative 6, check. 2 goes to negative 4, check. And then 3 goes to negative 2. Yep, finally, there we go. So all along, I had the right answer. It was just this part that was messing me up. So, all right. There's another type of inverse problems I wanted to go over, and they'll go by a lot faster. So on the next page, sometimes you'll be given a problem like this where you have listed some coordinates and you're asked to find the inverse. So this is an easy problem. All you have to do is switch them. By definition, inverse function means x and y get switched. So that's all I'm gonna do here. Okay, negative 3 goes to 1, 3 goes to negative 2. The only thing I guess I would say to be careful here is keep your negatives, don't drop them. Okay, 1 goes to 5 and 4 goes to 6. Okay, here's another example you can try. And then the other type of inverse problems you might see are find the inverse using a graph. And what I can tell you is here, the same thing, just pick some coordinates. You have 2, 3. I have a coordinate here which is 1, 0. I have a coordinate here which is the x is 0, y is negative 1. This is x is negative 1, y is 0. And then we have here negative 2, 3. Okay, and then now to find the inverse, I'm going to switch each of these coordinates and then I'm going to graph them here. So if I switch this is going to be 3, negative 2. So positive 3, negative 2. I'm going to mark it just to make sure. I'm going to switch to 3, 2, 3, 2. 1, 0, so that would be x is 0, y is 1, 0, 1, and then 0, negative 1, so that would be negative 1, 0, 0, negative 1, 0, so that's 0, negative 1. That was a confusing one. And then negative 2, 3. So that would be 3, negative. Oh, I already did that one. Okay, I think I have enough, so let me connect these dots. Just show you what the inverse function looks like on a graph. Okay, so I have the inverse. I have the original graph here, and the inverse graph looks like this. One thing I wanted to tell you is the inverse function on a graph gets reflected over this line right here, this specific diagonal line right here. Okay, it gets reflected through this. Just something about this line is it goes through the origin right here, and it's a perfect diagonal line, and this line here is called y equals x. So the inverse function is reflected over y equals x. Okay, what that means is each of these points gets reflected, meaning like if it's let's see, if it's like this, and then so if it gets reflected, here's the point right here. That's the same point we have here. Okay, same with this one. If it gets reflected, it goes here, and then it goes right here. That's your other point. Okay, again, you're not gonna have many graphing ones, but I just wanted to show you that this is what happens. It gets reflected, and then how does this get reflected? It just goes, so you have 1, 2, 3, and then this point. See, we have that point right there. Once you do that, it gets there it is right there. Okay, it's the same graph here. So I have some more examples for you to try. Here's a graphing one. Here's some other problems. Okay, let me know if you have any questions.